our 2D memo. Here's our table of items. Now, the safe item number over on the left. Mostly what this means is, which item am I thinking of stealing? Now, the row 0 is basically going to be filled with zeros so that I can easily look at the row above me. If I didn't have the row filled with zeros where I haven't picked anything, then I would have to have special cases. I would have to say, like, well, if I'm in row X, then never ever look above me. Only look at what I can currently do. So this makes it actually easier to write, to have that row of zeros in there. And actually also notice there's a column of zeros for a knapsack of capacity 0. And that makes it easy to look left. If I didn't have that column in there, I'd have to have another special case in my code. This just makes the code a little bit easier. So every value in this table is the best value I can get for a given capacity and a given item number. So like right here, this is the best value I can get for a knapsack of size 8, having stolen nothing. And if I was down here, for instance, that would be the best value I can get for a knapsack of size 8 after having considered items 1, 2, and 3. It doesn't tell me whether I've stolen it or not. It's just saying this is the best value you can get when you've thought about items 1 and 2 and 3. And we're going to go top to bottom. So let's go through this, and it'll get a bit clearer as we go. So we go to the very first one. All right, so I'm working on stealing item number 1. Well, in a knapsack of size 0, can I steal this item? No, it doesn't fit. Okay, so there's a 0 there. How did I get that 0? It came from someone in the table. It came from the row above me plus 0, basically saying anytime I'm anywhere in the table, my value, whether I pick item 2 or don't pick it, my value could be at least as good as the best one above me. So if I move down in the same column, that's saying don't pick it. So I take the value above me and add 0 because I didn't pick this item. Now here, that's my only choice, is don't pick the item. Now, what about a capacity of 1? Let me just erase that a little bit. Okay, so now for a capacity of 1, I could either take the value above me and add nothing, or I could take a value somewhere to the left of me and add the value of item 1. Now, think of it this way. I'm working on a capacity of 1. This item is of size 1. I need to look 1 column to the left of me. So it's basically this one plus 0, or this one plus 1, which is the value of that item. So I put 1 in there. I say, hey, that's the best way to get there, is to steal this item. Of the 2 possibilities, row above me and don't steal, or some column to the left of me and do steal, I take the maximum of those 2 things. Thing above me, and really it's not thing to the left of me, it's thing above left of me. So it was this one and take it, or this one and don't take it. All right, now, is there anything else we can do with item 1? It's going to look like this the whole way through. It's always going to be this one or that one, this one or that one, this one or that one. It's just going to be a bunch of 1s all the way through, because it's always either the thing above me or the thing up left of me, whichever's highest. And remember, it's always the thing above me plus 0 or the thing above left of me plus the value. Okay, so we've got that. Now we start item 2. So now, this is the best way to steal or not steal item 1. We don't know if we stole it or not stole it. We're going to rebuild the solution later. We're just trying to get the value for now. Okay, so we start on item 2. Item 2, can we do anything in a size of 0? No, so we take the value above us and add nothing. All right, now for a size of 1. Well, I could either take the thing above me and not steal item 0, or I could move how many columns left of me? 2 columns left. Can I go 2 columns left of column 1? No, so I've only got one choice. It's the value above me and don't take this item. Now, next one is, I could either go the one above me and add 0, or row above me and 2 columns left and do take it and add the value of that item, which is 6. That's the best way to choose that item. Now, let me just erase a bit here. All right, so now we're working on this one. We say, okay, I could either take that or go back 2 columns and add 6 to it. The best is 7. That's if I do pick the item. And now everything looks the same after that, because it's always take this one or take 2 columns back plus 6. It's 7's all the way out. Yeah.
Explain why you go up and to the left again.
Okay, so I have to go up because it's the row above me is I have not picked item 2 yet. So when I'm picking item 2, I have to go, well, what could I do from row 1 to get to row 2? So to go from row 1 to row 2, I could either go above me and don't pick it, or some number of columns left above and pick it.
So you have space for that capacity?
Yep, so we have space for that capacity. So that's why we could only do this in column 1, because we couldn't move back 2 columns.
Right.
Okay, any other questions? It's good to get them out of the way now, so it makes more sense as we move along. Yeah.
I don't understand what exactly it means to move 2 columns over.
Okay, so let's just go back, backwards. Let's go to this one. So I'm trying to fill in this location, right? So this is a knapsack of size 4. So I could either take the one above me and add nothing. That means I don't take item 2. Or I could move back 2 columns. I move back 2 columns because the item is size 2. So think of it this way. I'm working on a knapsack of size 4, and I'm trying to add an item of size 2. That means I would have had to have started with a knapsack of size 2 and added an item of size 2 to it. All right? So that's this one over here. So we always pick the best. So we get 1 plus nothing, the one above me, or 1 plus the value of the item, the one up left of me. And it's left by the number of columns of the item size. Okay, so now we're good with row 2. Let's go to row 3. So row 3, the first one is impossible. We just pick the thing above us and add nothing. Now, I'm saying I'd like to pick item 3. Well, item 3 has a size of 5. So until I get to column 5, I can't go back 5 columns. So until I get to column 5, the only choice is value above me, because I can't go back 5 columns from column 2. All right, so now I'm working on column 5. So I can say, hey, I could either do that and add nothing, or I could go back 5 columns and add what? 18, the value of this item. So I pick what's better, 7 plus nothing or 0 plus 18. That's what I put there, the maximum of those 2. Now, it's going to get more interesting now. Now we move over another column and I say, okay, I could take 7 plus nothing, or I could move back 5 columns because it's an item size 5 and add 18 to that. That gives me a 19. Now, I could say, okay, well, next one, I can either take the one above me and add 0, or the one 5 to the left of me and add 18, which gives me a 7 plus 0, or 6 plus 18 is 24. All right, next one, 7 plus 0, or 5 columns back and add 18. We put a 25 there. The best, it's always the maximum. So thing above me or thing some number of columns up left of me, plus the value, pick the best. All right, and then from here, because now everything is the same, it's 7 or 7 plus 18, we get 25s all the way out. All right, next row. We're working on item 4. So this one has a size of 6. So until we get to column 6, our best choice is thing above me. I don't pick item 6, or sorry, I don't pick the item of size 6 if it won't fit. And it won't fit until I get up to a capacity of 6. So now at a capacity of 6, it could be the thing above me or the thing 6 columns back plus 22. So we would put, so I say 19 plus nothing or 0 plus 22. Let's put a 22 there. All right, next one. I could say, okay, I could do 24 plus nothing or 1 plus 22. Now picking it is not the choice. Not picking it is better. So I'd have a 24 there because 24 is better than 1 plus 22. Next one, I could go 25 or 6 plus 22. 6 plus 22 is better. We put a 28 there. 25 or 7 plus 22. 7 plus 22 is 29. Then we get, again, 25 or 7 plus 22 is 29. And now we've got 25 or 18 plus 22. 18 plus 22 is 40. That's what we've got here. Now we haven't considered item 5 yet, so we're not done. We don't know whether we're done or not. We got to finish the last item, pick or don't pick. All right, let me erase my markings. So we move to the next row. We're considering item 5. So we start out with a 0, and we've got zeros all the way until we get to column 6, because these are all row above me, is the only choice I can make. I can't go back 7 columns. Okay, so now it's, should I go here or there plus 28? 24 or 0 plus 28. Let's do 28. 28 or 1 plus 28 would be 29. That's better. Okay, how about 29 or 6 plus 28? 29 or 6 plus 28, let's go 34. 29 or 7 plus 28, 35 is better. And then 40 or 7 plus 28, 35, 40 is better, and 40 is the final answer. This is, for a capacity of 11, and having considered every possible item, pick or don't pick, 40 is our value. Now we don't know what we picked yet, we just know we got a value of 40.